And we're live. What's up, guys and girls? This is Show Techno coming at you on the 1st of March, talking about Sabre stool tops. 1st of March. March 1st. We are live. We're talking about these stool tops, so stools for schools, and we're going to be building out one each in this class. This is a close to finished product. It needs finish on it, but it's what we're going to draw to scale on graph paper first, just so we're all on the same page with what we need to build, okay? So we're going to take this and scale it down so it fits on the paper. Our finished dimensions on this are 11 3/4 by 11 3/4. So we're going to start out with a rough size of 12 1/4 by 12 1/4. That gives us a 1/2 inch to trim overall around the whole perimeter, which should be enough if in case you don't get your board ends glued up or whatever. So my question to you, block one, is what's an appropriate scale to fit a 12 inch by 12 inch cube or square onto a 7 inch by 10 inch space? That's about what we got here. Yep, 7. What do you think would be a good scale? Let's go back and review a little bit. What's the scale we used to build the shed? 1 to 12. So if we did a 1 to 12 of this, how big would it be on paper? If it's 12 inches in real life, how big would it be on paper? It'd be a 1 inch on paper. So if we draw a 1 inch square here, that's not very big. So 1 to 12 is not good. So now with that in mind, think what would be the next maybe scale we could go to? What's another ratio or scale we could think about? 1 to 2. That would make it a 6 inch by 6 inch square. I like that one, except if I do 6 by 6 and I'm really tight, I only have an inch up here. I want to show a front view like this. That's my most detailed. And then I'm going to show a side view on edge, and I can't probably fit both of those in there. So a 1 to 2 would be great. We could use bigger paper, but what's one more scale we could go that would maybe be somewhere in the middle of that and still is good numbers? 1 to 4. Let's talk about a quarter scale, 1 to 4. So 1 to 4, if it's 1 to 4, that is definitely another -10, Grant. That was recorded on here. Did you hear him drop his ruler? Multiple dents. A 1 to 4, if it's 12 inches in real life and it's 1 to 4 scale, how big is it going to be on paper? How wide and how tall? 3 by 3. Now, are we figuring that 1/4 inch in here? 1/4 of a quarter, it'd be like 3 1/16 inches. So let's draw a 3 by 3 square. I'm going to go up and in about 1.5 inches, something like that. So 6 blocks over, 6 blocks up. And then I'm going to draw a 3 inch square. 3. I don't even have enough room for my ruler here. I shouldn't draw these corners and I'll end up erasing them because we're going to round them, but we can make that detail in a little bit. 3 by 3. If you want to be super exacto, you would go 3 1/16 by 3 1/16. I'm not going to get that fussy. That's our front view. We're going to project, and that's the correct term. Let's see if I can adjust this up a little bit. 0.6, 0.5, there we go. So front view is this. Projecting a top view means we turn this on edge and look at it like this on edge. So it goes directly above. Take a look at this. We want to leave space for dimensioning about 1 inch. And then we're going to project up. I'm going to make 2 points right here and right here that go straight up off of my front view line. So I'm just going to make a point 1 inch up, point 1 inch up. If this is 1 1/4 inches thick and I want to show 1/4 scale, how thick is it going to be on paper? It's 1.25 inches in real life, and I want to show 1/4 of that. That's a tough one mathematically. What do you think it would be? If it was 1 inch thick in real life, what would it be on paper, 1/4 scale? Be a 1/4 inch, so 1 square thick. So we're going to be 1 1/4 inches, so that's actually 1 square plus another 1/4 of a square. So 1 1/4 squares up to show our thickness, 1 1/4 squares up, and then we just connect those two lines together. This would be our top view. All right, Intro to Engineering Design kids. Wirens, you were in there, weren't you? Andrew? Were you in Intro to Engineering Design? Oh. Who was in Intro to Engineering Design? Why would we not need to draw a right side view?
Because it's a square.
It's the same thing. It's a simple profile, so it doesn't give us any more detail to draw a third or a right side view. Yes, yes. All right, let's draw in a little more detail here now. We're going to do this on the fly. We're going to radius these corners. And we use this simple method to make the corners on this. We actually use a art department paint cup, and we put it in on the squared corner and mark it out with a pencil. And then we'll end up rough cutting it with the bandsaw, finishing it off on the sander. That radius corner right there, how do I figure out what the radius of that is? How would I do that? Measure it. Okay, the diameter of it is 3 inches, right on. How my left-handedness, I'm so bad with that. 3 inches, let's call it 3 inches. So our radius is 1.5 inches. So that's the radius we want in the corners. And now we've got to scale that down to 1/4 of its actual size. Oh, scale. So what's 1.5 inches on paper here? We've got maybe we should have done this right away. 1 square equals how much in real life? Nope. It's a 1/4 inch on paper, but how much does it equal for our 1 to 4 scale? So our scale is 1 to 4. I should have wrote that right away. So that means a 1/4 inch equals how much in real life? An inch. Yep. So 1 inch on paper equals 4 inches in real life, or a 1/4 inch on paper equals 1 inch in real life. So we're going to go 1 inch in real life. This would be 1 inch. If we go 1.5 squares up and 1.5 squares over, that would be right here in the center of this. Oh, let me zoom in, guys. Sorry. We are radiusing these corners right now. So if I go 1.5 squares up and over, that would be my point from which that'd be my compass pivot point, if that makes sense. And that means that we would start the curve right here and end it right here. And then I'm just going to draw this in to the best of my ability to show that rounded off. And it's not that awesome, but I'm going to do that on all 4 corners. I can do better on the second one. So we go 1.5 inches in from each of the corners in both directions. And then draw in those radiuses. I am not that good at drawing those in freehand, I have to be honest. Still borrowing ruler denter's pencil here. I'm going to then erase out my solid corners. Soundtrack provided by SHS Band and Choir. All right, how we doing, people? Grant, here you go.
Yeah, I was wondering what that was.
You didn't even catch that. I got it on.
Knock it out.
You didn't even see it, people. How we doing? Radius corners? Okay. A little bit more detail, and then we're going to dimension this out. Ready to move on? Good? Okay. Let's do this. Okay, additional details. We can actually start dimensioning here. Rules of dimensioning. This is, again, our Intro to Engineering Design kids. Whenever possible, we want to put dimensions between the views, and we never want to put dimensions inside of our drawing. This is a sacred space. So I'm going to put an overall width dimension that's shared between here. Extension lines. This is a lot, but stick with me. I want to leave a little gap between the edge of the solid object, and then I'm going to draw a light line like this on both sides. This is called an extension line, and then I will put a dimension line in between it that looks like this, leaving a space in the middle, arrows, and I'm going to write 12.25 inches. Yeah, I should, yeah, 12.25 rough, 11.75 finished. Kill two birds with one stone. I'm going to do the same thing for my height, and I'll put it over to the right here. So extension line out. Dimension lines. Oh, let's do. I need an eraser. Man, I did not start prepared this morning. There we go. We're going to mess with you a little bit. 12.25 inches rough. 11.75 inches finished. A few more details we got to put in. We are going to indicate what the radius of the corners is. And my corners, I am not proud of. They're not even. There, that's a little better. That has to come off at an odd angle. So whenever we're indicating radiuses, they come off at an odd angle with an extension line and then flat out like this. And we would do radius, so R, well, let's just write radius. 1.25 inches. Oh, let's go all in on this. TYP. What does TYP stand for, Grant? If I do that, what does that mean for all the corners?
Typical.
Yeah, typical. It means that all four are the same. So radius 1.25 typical. Nice job. I'm going to make a note here, and again, on my drawing, I'm trying to affect it after the fact. I'm rounding these over, but I'm going to put another one of those right here. And that is going to be a 1/4 inch round over. And I'm going to put all edges. Now, what are we talking about there? That is what we're going to do with the router. So we're going to watch Router 101 with the Perkins brothers, and you're going to get to router all these edges with a 1/4 round them off. So that's different than this big radius here on the corners. We'll cut that, but all of these are going to get rounded over with a router. And my drawing is not, I don't have an eraser. I've got nothing. Yes, I do. Here we go. There we go. Even though this is super macro, I still want to show a little bit of a round over here. Make it look. Okay, last part about this, and this is where we'll get to today with glue up, is this is going to be made up of a number of boards glued together. Now, if we look at this one, you can see there is segments every, like, let's see here. Can you see that? Okay. Each one of these is individual boards. You see that? Okay, and the direction of the grains, we want to alternate these to be rainbows and smiley faces. So I want you to draw some vertical segments. They can be random. I'm going to even use my ruler here. They can be random lengths because the boards are going to be cut to random lengths. Probably no more than like 3 or 4 inches wide. And then I want you to draw rainbow wood grains on the first one and smiley face wood grains on the second one. Rainbows on the third. Smileys. And rainbows. And we'll make a note in here, alternate annular rings, alternate grain direction. Something like that. I'm going to put my name on this because when it gets blown off of my baking rack, I'll be able to reclaim it. This is Sabre stool tops. (3/1/23). In this case, period 1. We're going to call this good for now and scene.